Welcome to this physics lesson on cell EMF and internal resistance. This is an important topic in Class 12 physics for CBSE and NIOS students. Let's start by understanding what a cell is. A cell is a device that converts chemical energy into electrical energy. A battery is actually a combination of multiple cells connected together. The electromotive force, or EMF, is the maximum potential difference that a cell can provide between its terminals when there is no current flowing. The EMF of a cell is denoted by the Greek letter epsilon, and is measured in volts. All real cells have some internal resistance, which is the resistance of the electrolyte and other cell components. This internal resistance is usually denoted by R and is measured in ohms. Let's look at the equivalent circuit of a cell. We can represent a cell as an ideal EMF source epsilon in series with the internal resistance R. When a current flows through a cell, the terminal voltage V is different from the EMF epsilon due to the voltage drop across the internal resistance. We can write this relationship as V equals epsilon minus IR, where I is the current flowing through the circuit. Let's understand the effect of internal resistance on a cell's performance. When current flows, there's a voltage drop IOR across the internal resistance. At high currents, this voltage drop becomes significant, reducing the terminal voltage. When no current flows, open circuit, the terminal voltage equals the EMF. How do we measure the EMF and internal resistance of a cell? We can use a potentiometer to measure the EMF directly without drawing current. Another method is to measure the terminal voltage V for different values of current I, and then plot a V versus I graph. The y-intercept gives us the EMF, and the negative slope gives us the internal resistance. Let's discuss some practical implications of internal resistance. Due to internal resistance, there's power loss within the cell, which causes heating. This power loss can be calculated as I squared R. The efficiency of the cell decreases as more current is drawn. Let's summarize what we've learned. EMF, epsilon, is the maximum potential difference of a cell when no current flows. Internal resistance, R, causes a voltage drop when current flows. Terminal voltage, V, equals EMF minus the product of current and internal resistance, V equals epsilon. IR understanding these concepts is crucial for designing efficient circuits and power supplies. Thank you for watching this video on cell EMF and internal resistance. I hope this helps with your Class 12 physics studies for CBSE and NIOS exams.